Good morning, ladies and gentlemen. Today we're on page 91 of your student journal, and our objective or our goal for the day is, today I will use multiple strategies to find the GCF. Okay, so this is a new topic, so we have all new vocabulary. So let's look at our first vocabulary word, and it says prime numbers. So numbers that have only two factors, one in itself, numbers that have no positive divisor other than one in itself. So prime numbers, the first prime number is 2, that's the smallest, and it's because the only way you can get to 2 is 1 times 2. 3 is my next prime number because it's 1 times 3 are its only factors. 4 is not a prime number because 4 is 1 times 4 or 2 times 2. 5 is a prime factor or a prime number because only 1 times 5 works. 6 is not because I can do 1 times 6 or 2 times 3. 7 is a prime number because it's only 1 times 7. 8 is not because 1 times 8 or 2 times 4, so it has 4 factors. 9 is not because I have 1 times 9 or 3 times 3, so it has 3 factors. 10 is not because we can do 1 times 10 or 2 times 5, but 11 is because 1 times 11 is the only factors. 12 is not because it has 6 factors, 1 times 12, 2 times 6, or 3 times 4, but 13 is prime because I only can do 1 times 13. And we could go on, but I think we'll stop at just those 6. So those are some examples of prime numbers and why they're prime. Our next vocab word is the most important thing since this is what we're finding. It's our greatest common factor, also known as our GCF. And it's the largest divisor that evenly divides into given numbers. So sometimes I think of factors as fitting in. And then they give us 2 methods. They give us the ladder method, the factor tree method, which I'm not going to be using this method. You are welcome to use this if this method works well for you. I'm going to be using the ladder method, and then I'm also going to be showing you another method. Okay, so for the steps for the ladder method, we're going to write the numbers on one line, draw the L, divide out with prime numbers smallest. Keywords, you have to use the smallest prime number, and then we're going to multiply everything on the left side. Okay, we're also going to do a method called steps for listing factors. I'm going to also show you another method. So steps for listing factors, our first step is start with 1 and then stop when you have a repeat. Okay, so those are going to be the 2 methods that I'm going to be showing you, our 2 different strategies. So the ladder strategy and then just listing our factor strategy. Okay, so I'm going to get started on my first problem, which is 18 and 24. So for the ladder method, it says write the numbers on, and you can follow along with your steps with me. Write the numbers on one line. So I have 18 and 24, and then draw my L shape. And then divide out common prime numbers starting with the smallest. So my prime numbers are 2, 3, 5, 7, 11, and 13. So I start with my smallest. Can I divide both those by 2? Yes. So I'll put a 2 there. And when I divide them by 2, I get 9 and 12. So then I try it again. Can I divide those both by 2? No. So then I try my next smallest number, prime number, 3. Yes, those both will divide by 3. And when I divide them by 3, I get 3 and 4. And then I start over. Can I divide those both by 2? Nope. Can I divide those both by 3? Nope. And then I can't go anything bigger because I have a 3. So I just have to stop. Okay, so then it says I'm going to multiply all the factors that are on the left side. So I'm going to multiply those and I get 2 times 3, which is 6. So that is my GCF, 6. So another strategy I could have used would be listing them. So I can list out the factors for my two numbers. And my first step says start with 1. So I'm going to say, how do I get 18? 1 times 18. And then it says stop when you have a repeat. So I'm going to go to my next number. 2 times 9, 3 times 6, and I just keep going. 4 times doesn't work, so I skip it. 5 doesn't work, so I skip it. And then 6 is a repeat, so now I stop. So my factors of 18 are 1, 2, 3, 6, 9, and 18. So for 24, it's 1 times 24, 2 times 12, 3 times 8, 4 times 6, 5 doesn't work, and 6 is a repeat. So my factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. So my common factors are 1, 2, 3, 6, and nothing larger. So 6 is my GCF. So there was 2 different strategies I could find it. I'm going to show you how to simplify this and make this even shorter if you like this strategy. Okay, so let's try another one. I have 24 and 48. So I'm going to list them both on one line, draw my L, and then start with my smallest prime number, which is 2. So can I divide both those by 2? Yep, so I'll put a 2 and then divide. And then I try it again. Can I divide those both by 2? Yep, so I do it. And then I try it again. Can I divide those both by 2? Yep. And I do it. Can I divide those both by 2? No. Those will not both divide by 2. So when I now have to stop, I can multiply these out. Oh, I saw a mistake, ladies and gentlemen. I was wondering about that. I apologize. 12 divided by 2 is 6. Okay, so can I divide those both by 2? No. But could I divide them both by 3? Yes. So I get a 1 and a 2. Now can I divide? No. Okay, so that was my mistake there. So now I can multiply those and I get 2 times 2 times 2 times 3, which is 4, 8, 24. So my GCF is 24, or if I use the other strategy of listing, my numbers are 24 and 48, but here's the shortcut. You actually only have to list them out for the smaller of the two. So I only have to really list them out for 24. So I'd get 1 times 24, 2 times 12, 3 times 8, 4 times 6, 5 doesn't work, and 6 repeats. So once I list them for the smaller one, I can just check them for the larger one. And I'm looking for the greatest, so I want to check the greatest. So I first check 24. Does 24 fit perfectly into 48? Yes. So that's my answer. So this is the strategy I really like, but this strategy works as well. Okay, let's try some together. We are on page 92, and here's our first one together, 60 and 45. So let's do the ladder method first. So we're going to set them up on one line, put our L, and then start with our prime numbers. So our first prime number is 2. 2 won't fit into 45. 3 is our next one. 3 will work on both of them. So if I divide them both by 3, I get 20 and 15. Okay, then we try again. We start with 2. 2 works, but 2 does not work for 15. Then we try 3. 3 does not work for 20. Our next prime number is 5, and 5 will work for both of those. So I get 5, I get 4, and 3. And then 2 doesn't work, and 3 doesn't work, and I can't go any higher. So our GCF is 15. Or our other method is we could have listed them out. And remember, we only have to list them for the smaller digit. I'm sorry, smaller number. So I have 1 times 45, 2 doesn't work, 3 times 15, 4 doesn't work, 5 times 9, 6 doesn't work, 7 doesn't work, 8 doesn't work, and 9 repeats. So then I just check my largest one. 45 is not a factor of 60. 15 is a factor of 60. So 15 would have been my answer. So you can choose which method you like best. Okay, let's try our next one. It says 18 and 63. Okay, so let's do our ladder method first. Okay, so we start with 2. 2 can fit into 18, but 2 can't fit into 63 because it's odd. So let's try 3. 3 can fit into 18, and 3 can fit into 63. So I'm going to divide them both by 3, and I get 6 and 21. Okay, let's try it again. 2 can go into 6, but not into 21. 3 can go into 6 and 21. So I get 2 and 7. Okay, and then when we try it again, we get 2 can fit into 2 but not 7, so there's nothing else. So our answer is 9. Okay, if we were going to try the other method, we list them out and we only have to list out them for our smallest number. So we have 1 times 18, 2 times 9, 3 times 6, 4 doesn't work, 5 doesn't work, and 6 repeats. So then I ask myself, can 18 times something equal 63? And if you're not sure, you might need to do some side work on this. I know that 3 times 18 is 54, and 4 times 18 would be too much, so that doesn't work. Is 9 times something equal 63? Yes, 9 times 7. So I know my answer is 9. So again, both methods would work. You would have to choose which method works best for you and which one you understand the best. You have the next couple pages to try, and have a nice afternoon. Bye.